All right, for part 2 of our final lesson in this unit, we are going to dive a little deeper with parallel and perpendicular lines. We spent the last time just making sure that we could write linear equations like we did in Algebra 1. It was all review, nothing new. Here, this is going to be half new information, half old information. But we're going to continue with this idea of applying slope with parallel lines and perpendicular lines, specifically working in the coordinate plane. And so all of this information you should have in your last set of notes. But it's helpful maybe to put this down today to make sure that you have this information handy, that you can reference it so you can do the activities that we're going to attempt to do. There's also some new information, like I mentioned, a couple theorems about horizontal lines and vertical lines. So any two non-vertical lines are parallel if and only if their slopes are equal. All right, so parallel lines have the same slope, right? That's kind of how we discussed that idea of parallelism in Algebra 1, right? That parallel lines have the same slope. Well, all vertical lines are going to be parallel to each other. Just like all horizontal lines are parallel to each other, all vertical lines are parallel to each other. The reason why we're making this as a separate statement is because the slope of vertical lines is undefined. Of course, if we have horizontal lines, the slope is 0 and the slope is 0, so those are the same, so those lines are parallel. Theorem 2.14. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. That was articulated a little bit differently in Algebra 1, and that's okay. We're going to talk through that, or we're going to arrive there in just a little bit. But if we find the slope of one line and the slope of another line, we multiply them together. If it equals -1, then hey, those lines are perpendicular because their slopes multiply to give us -1. Every vertical line and horizontal line are perpendicular to each other. That is a fun fact. All right. So we are going to do a couple examples here to check parallelism and to check perpendicularity. So on your graph paper, try your best to plot these points. I realize that you can't read them very well. They show up nice on my PowerPoint, but when you're on the video screen, you're not going to be able to see. This is line 2, this is line 1. I've got a couple x comma y's here, and I'm going to write out those numbers so that you can see them better. This is 1 comma 5. This one is 3 comma 3, this is 1 comma -4, and this is -2 comma -4. Go ahead and plot those dots on the coordinate plane. And what we're going to do is we're going to use slope here in just a minute for the slope of line 1. I'm going to write M1 for the slope of line 1, and we're going to use the y2 and y1 from that line to find its slope. For line 2, we're going to use its 2 points to find its slope. All right, so we've got two different lines going on here. And for line 1, that's this guy right here. This is line 1, that's line 2. So I'm just going to work left to right here. So this is point 2, this is point 1. I've got 3 minus -4 on the y's. I've got 3 minus 1 on the x's. And so that gives me 7/2. These lines appear to be parallel, but we're going to confirm that they are, or we're going to confirm that they're not. Maybe they don't look parallel, and we're going to say that they're not parallel, but we're going to show it with slope. Over here, we've got 5 minus -4, and we've got 1 minus -2. When we do this, already you can tell, uh-oh, I got 9, and I got 3, that makes 3. This is 3.5, right? These things are not the same. So here's what we're going to write. This is what's really important. This is the most important part. And you can actually put this underneath. I'm going to write that the slope of line 1 does not equal the slope of line 2. Therefore, line 1 and line 2 are not, where's my red marker? Donde está? Aquí está. Are not parallel to one another. All right? Those slopes are not equal, so those lines are not parallel. That's kind of instead of writing out the slopes are not equal to each other, therefore the lines are not parallel, we can write out this in symbol form. And that is the same sentence just written out with figures. We can do the same thing with perpendicular, all right? So we're going to find out what the slopes of these lines are, and then we're going to ask ourselves, do these lines' slopes multiply to equal -1? All right? And again, you can't see these lines very well, but this will be line 1, this will be line 2. I've got the point right here that is -4, 1. I've got this point over here on line 1 that is 5, 5. On line 2, I've got 0, 5. and then I've also got 3, -2. You can plot those on your graph paper, use a ruler to connect those dots so that you can draw those effectively in your notes book. All right, so for line 1, I'm going to take the second minus the first. That's generally the way that we roll. So the y value is 5 minus the y value of 1. The y value is 5 minus the x value of -4. This gives us 4/9. On the other one, we have -2 minus 5 over 3 minus 0. So I get -7/3. So you can probably tell already that these are not going to multiply to equal -1, but we're going to check it anyway. All right, the slope of line 1 times the slope of line 2 is going to be 4/9 times -7/3. This gives us, it's so close. It's almost 1. We are off, I'm sorry, not 1, -1. We are off by 1/27. These look so close to being perpendicular, but we can't go by sight alone. We have to use the math to back it up. And so since the product of the slope of line 1 and line 2 does not equal -1, since it does not equal -1, line 1 is not perpendicular to line 2. All right, now if these were equaling -1, then we would say that line 1 is perpendicular to line 2. If the slopes were equal on the last example, we would say yes, line 1 is parallel to line 2. But we're going to use math to back that up, all right? That's a little time consuming. Usually these videos are a little bit shorter because I don't have to do so much algebra. It just kind of works itself out, right? We have logical conversations instead of math step by step. All right, so that took a little bit longer. Explain whether or not these lines are parallel using slope. Well, here it's like, well, I don't know what the slope is. We're not graphing them. I can't find the points, etc. Well, we do have y equals mx plus b, and the m here is -5. Over here I have, oh, x equals. I need to get this into y equals form. So I'm going to subtract 4. I'm going to multiply both sides by -1/5. Let's see, plus 4/5 equals y. And if we don't like it that way, we can use the symmetric property of equality to rewrite it so that the mx plus b is on the other side. Oh my gosh, there's fractions, what do I do? Well, it's okay, we can still identify that the slope is this rise over run. But let's multiply those. When I take the slope of line 1 and I multiply the slope of line 2, I get +1. All right, since it's not -1, these lines are not perpendicular. Oh, we were talking about parallel. -5 does not equal -1/5. Therefore, the lines are not parallel. All right, you guys okay with me using the symbol for perpendicular and the symbol for parallel? This was supposed to be parallel, and I did perpendicular, but you guys get the idea. We found the slopes, and the slopes are not the same. Therefore, the lines are not parallel to each other. Maybe I get to skip this example. Oh, look at this. I did it already. Look at that. We checked it before we wrecked it. Actually, we wrecked it, and then it turns out that we needed to do it. So there we go. So we've also shown that these that these lines are not perpendicular because the slopes don't multiply to equal -1. They multiply to equal +1. All right. Here is the punchline. All right. This is the big punchline, and this is kind of the direction that we've been moving. And this is, again, to kind of finalize the work that you've done in Algebra 1, and that is, let's write the equation of the line that's parallel to this one and passes through this point. So for parallel to, we need same slope. The slope in this line is 1/2. So we're going to use that slope of 1/2. And we're going to have y minus y1 is equal to m times x minus x1. So y minus y1 is equal to m times x minus x1. The y1 is 1, the x1 is 4, the slope is 1/2. So the equation of the line in y equals mx plus b form, that passes through 4, 1 and is parallel to 1/2 x minus 3 is going to be this line right here, y is equal to 1/2 x minus 1. This is the equation of the line that is parallel to y equals 1/2 x minus 3 and passes through that point. There's only one answer there because we have that theorem that explained in the last lesson, or maybe, I'm sorry, it was 2 lessons ago, that through a point, given a point and a line, there is one line through the point that's not on the line that is parallel to the given line. All right, that was in the triangle angle sum lesson. Let's do the same thing, but let's do perpendicular to. So perpendicular to, this is a little crazy to think through. We're going to change this part. We have the same x comma y. We're just going to find the right slope. For perpendicular to, I need for 1/2 times the slope that we're going to use to equal -1. All right, the slope of the line perpendicular to the original one. So I'm going to multiply both sides by 2, and it gives me this. This is the slope that we are going to use, -2. So let me put that slope in here, and that will give us the opportunity to write the equation of the line that is perpendicular to the one that's given. Y minus y1 is equal to m times x minus x1. We substitute our values for x1 comma y1. We substitute the value for our slope. Sorry for my handwriting there. That's a -2. And we are good to go. Now you did this in Algebra 1, but it's been a while, right? It's been, well, you probably learned it 2 years ago, but we would have practiced it last fall, so roughly a year ago. Although you would have learned it maybe even 1.5 years ago. And now we're reviewing it here. All right, you're going to try this one. You're going to write 2 equations for the line that's parallel to this one and the line that's perpendicular to that one. You get to try this one. I know that's not fun for you, but pause the video and you try to do this. We'll go over that in class. The goal is that you can use the slope and apply that to parallel and perpendicular lines to write equations and to understand the relationships. All right? The video turned out a little longer than I wanted it to, but still about 12 minutes. Hope that worked out all right for us. Let me know if you have questions. See me in seminar.